In this video, we're going to look at CC5, which is ionic bonding, a topic that comes up on paper 1 and on paper 2. When we're looking at ionic bonding, we're looking at the bonding between a metal and a non-metal. And anytime we look at bonding and we look at chemical reactions, we need to look at what happens in terms of electrons. Metals will always lose electrons, and non-metals will always gain electrons when they react. And they do this to get a full outer shell. When metals lose electrons, they form positive ions, and when non-metals gain electrons, they form negative ions. It may seem a little counterintuitive to gain something and end up with a negative charge, but if you look at electrons, they themselves have a negative charge. So to gain an electron means you're gaining a negative charge. If we look at a reaction between a metal and a non-metal, I've chosen sodium and I've chosen chlorine. Again, the reason I know sodium's a metal is because of its position on the periodic table. The metals are all to the left-hand side of this line, and the non-metals are to the right-hand side. Sodium's over here in group 1, it's a metal. Chlorine's over here in group 7, it's a non-metal. So the reaction between sodium and chlorine is going to result in an ionic bond. Because sodium's in group 1, it's got 1 electron in its outer shell. Chlorine's in group 7, so it has 7 electrons in its outer shell. In order to get a full outer shell, sodium will lose 1 electron. For chlorine to get a full outer shell, it will gain 1 electron. To have a closer look at why sodium loses an electron, you need to consider the full structure of a sodium atom. Sodium has 11 electrons in total, 2 in the first shell, 8 in the second shell, and 1 in the third shell. If it loses an electron, it loses it from the outer shell. And when it does this, its second shell becomes the outer shell, and its second shell is full as it has 8 electrons. This is why sodium will lose 1 electron to get a full outer shell. Chlorine is a little bit easier to understand. It's already got 7, it wants 8, therefore it will gain 1. So to show this, I'm going to draw an arrow from sodium to chlorine. That shows sodium loses 1 electron and chlorine gains. To draw this on the other side, I'm now going to draw sodium without any electrons, so just an empty shell, and I'm going to draw chlorine with its 7 original electrons, and then with the new electron it has gained from sodium. This is why I use dots and crosses. It doesn't matter which way around you do it, but you need to use dots for the electrons of one atom and crosses for the electrons of another, so that when you do the ionic bonding, you can see that chlorine has gained a new electron from sodium. As I mentioned above, if a metal loses an electron, it will have a positive charge. Because sodium has lost 1 electron, it's going to have a +1 charge. Chlorine has gained an electron, so it'll have a -1 charge. On the left-hand side, I have a sodium atom and I've got a chlorine atom. But as soon as they lose and gain electrons, I stop calling them atoms and I start calling them ions. So now I've got a sodium ion and I've got a chlorine ion or a chloride ion. Because you've got something positive and something negative, there's going to be an attraction between the 2 ions. And this attraction is called the electrostatic attraction. The definition for an ionic bond is as follows. An ionic bond is the electrostatic force of attraction between oppositely charged ions. If you're asked what an ionic bond is, you will not get any marks for saying the bond between a metal and a non-metal. You must use this definition. You get 1 mark for saying the electrostatic force of attraction, which is the attraction between something positive and something negative. And then you need to specify that you have got oppositely charged ions. Again, opposite charges attract, so it's important that you specify that they are oppositely charged. When you write the formula for an ionic compound, you will see that you've got the same number of positive ions and negative ions. So here I've got 1 sodium ion for every 1 chlorine ion that I've got, so I'll write my formula as NaCl. If we look at another example of ionic bonding, this time I'm using calcium and I'm going to stick with chlorine. Calcium's in group 2, so I'm going to draw it with 2 electrons in its outer shell. Again, I'm not drawing the full calcium atom here, I'm just drawing the outer shell because they're the electrons involved in bonding. Because calcium's got 2 electrons in its outer shell, it will lose 2 electrons. Remember, metals always lose electrons. If it's got 2, it will lose 2. And again, if we look at the full drawing of calcium, you'll be able to see why it loses 2. So in its fourth shell, which is its outer shell, it's got 2 electrons. If it loses those 2 electrons, the third shell becomes the outer shell, and the third shell is full. Going back to this example, I've got calcium that wants to lose 2 electrons, but chlorine that only wants to gain 1. Calcium can give 1 electron to chlorine, but in order to lose its second electron, it's going to need a second chlorine atom. If you've got 2 chlorine atoms, then calcium is able to lose both of its electrons. If I'm drawing this on the other side, again, I'm going to draw calcium, but this time without any electrons in its outer shell. Because it's lost 2 electrons, it is going to have a +2 charge. Then I'm going to draw my 2 chloride ions. Each one will have the 7 original electrons, but then 1 extra electron from calcium. Because each ion is gaining 1 electron, it's going to have a -1 charge, and the other chloride ion will be exactly the same. Again, what you can see here is that you've got the same number of positive charges as negative charges. You've got +2 from the calcium, and then you've got 2 -1 charges from the chloride ions. That gives you +2 -2 overall. To write the formula of calcium chloride, I write Ca because the metal always comes first, and then I write Cl, and I write Cl2 because for every 1 calcium I need 2 chloride ions, so it becomes CaCl2. Just note how I write that too. I write it as subscript, so it's down small. It's not the same size as the letters that I've written in the symbols. If we look at some classic exam questions on this kind of thing, you'll see that they do have quite specific answers. So for example, what is an ionic bond is for 2 marks. You get 1 mark for saying electrostatic attraction, the second mark for saying between oppositely charged ions. Again, you don't get any marks for saying the bond between a non-metal and a metal. Another common question, describe how an atom becomes an ion. In this case, we're talking about calcium. Calcium's got a 2+ charge. The plus tells you it's lost electrons. The 2 tells you it's lost 2 electrons. You get 2 marks for this. You get 1 mark for saying calcium loses electrons, but if you specify that it's losing 2 electrons, you'll get your second mark. The third is another typical question, and this is a 4-mark question. Describe in terms of electrons what happens when sodium reacts with chlorine. This is the reaction that we looked at, and all you have to do is describe what we drew in that diagram. So if I look at my diagram here, I can see that sodium is losing an electron to form an Na+ ion, that chlorine gets that electron from sodium and forms a Cl- ion. And just stating those 4 things gets you 4 marks. It's really important that you remember to include the charges on the ions because you won't get the marks without them. And it's also important that you specify where chlorine gets the electron from. You need some sort of sentence to indicate that the electrons are being transferred. So you can say sodium gives chlorine an electron, or the electron is transferred from sodium to chlorine, but you need some sort of sentence to indicate that you've got the transfer of electrons in order to get all the marks. If you were asked to describe the second reaction we looked at between calcium and chlorine, it's a little bit trickier, but it's the same idea. You'll get your first mark for just saying calcium loses 2 electrons, that's going to be mark 1, to form a Ca2+ ion. Remember to include the charges on your ions. The third and fourth marks you'll get are for the second sentence here. So I've got 2 chlorine atoms. They each gain 1 electron from calcium, so that will get you a mark, to form 2 Cl- ions. Note my use of the word atoms and the word ions, okay? On the left-hand side here, before they've gained an electron, chlorine is called an atom, and on the right-hand side, after gaining an electron, that's when I call it an ion. It's really important that you use those 2 terms correctly. You should only be using the word ion after it's gained an electron and has a negative charge. The other thing you need to be able to do is write the formula of ionic compounds. On the previous page, when we drew out our diagrams, we were able to work out what the formula would be. So for example, when we drew out NaCl, we saw we had 1 sodium and 1 chloride ion. The formula was just NaCl. The second reaction, we saw we needed 2 chlorines for every 1 calcium, so we knew it was CaCl2. Luckily, you're not going to have to draw those dot cross diagrams every time you want to work out the formula. Instead, you're just going to use the charges on the ions. In order to see the charges you've got on your ions, you're going to use your periodic table. If an element is in group 1, it will lose 1 electron when it reacts and have a +1 charge. If it's in group 2, it will have a +2 charge. If it's in group 3, it will have a +3 charge. Remember, metals always lose electrons and they always form positive ions. Over here on the right-hand side, you've got your non-metals. So you can see I've got gain electrons and I've got negative ions. Group 5, they gain 3 electrons, have a -3 charge. Group 6, a -2 charge. Group 7, a -1 charge. So using my periodic table, if I've got calcium, it's in group 2, it must have a +2 charge. Sulfur is in group 6, it must have a -2 charge. Phosphorus is in group 5, it must have a -3 charge. Rubidium is in group 1, it must have a +1 charge. So if you know how to use your periodic table, working out the charges and ions is really, really simple. Other charges you can be asked for are the transition metals, which are in here, this section of elements. You can see that you can't just look at the group to figure out what the charge is going to be. But because they're metals, you know that they will always be positively charged. With your transition metals, you will be given an additional piece of information. You need to know that they'll form positive ions, but you'll be given a number in Roman numerals next to the transition element that will tell you what the number will be. Is it +1, +2, or +3? If we look now at how to write ionic formula, we're going to use those charges. So magnesium is in group 2, it has got a +2 charge. Oxygen is in group 6, it's got a -2 charge. Again, I'm getting these just from looking at the periodic table. If the charges cancel, then you don't need to use any numbers. You just write down the letters MgO. So +2, -2, they cancel out. I don't need any numbers in my formula. It's just MgO. If I do the next one, calcium bromide, calcium's in group 2. It's got a +2 charge. Bromine is in group 7. It's got a -1 charge. In this case, my charges are not cancelling out. I've got +2, I've got -1. To do this, I then write down the letters Ca, Br. Again, I always put my metal first. And what I'm going to do is I'm going to cross over the numbers. So calcium is next to the number 2. I then cross that number over and put it down small next to the bromine. Bromine has the number 1. I cross that over and put it down small next to the calcium. I do not cross over the charges. I don't cross over the plus and the minus. I only cross over the numbers. So the 2 comes from calcium down next to bromine. The 1 comes from the bromide ion down next to the calcium. And I end up with CaBr2. That 1 there is not necessary. You don't need to write it. My final answer is CaBr2. There is no charges in my final answer, no plus and minus. Aluminium bromide, aluminium is +3. Bromine, again, is -1. Again, you'll see that these do not cancel each other out, which means I need to cross over the numbers. I write down the AlBr. The 1 next to the bromide ion comes down here next to the aluminium. The 3 from the aluminium comes down here next to the bromine, and I get AlBr3. Again, I'm not bringing the plus and the minus down, I'm just bringing the numbers, and you don't actually need to bring that number 1. Aluminium oxide, aluminium is in group 3 with a +3 charge, oxygen's in group 6, a -2 charge. They do not cancel out, I need to cross over the numbers. I write down AlO. The 2 from the oxygen comes down here next to the aluminium. The 3 from the aluminium comes down here next to the oxygen. I get Al2O3. That is my final answer. In the next example, I'm using a transition metal. I'm using iron. The symbol for iron is Fe. Again, I mentioned that these are in the central block of the periodic table, and you can't just look at the periodic table to figure out what the charge is going to be. But I know it's a metal, so I know it has to have a positive charge. And then if I look at what I've got in Roman numerals, I've got a 2 in Roman numerals, which tells me it's iron +2. Chlorine is in group 7, it's got a -1 charge. These charges do not cancel, so I write down my FeCl. The 1 from the chlorine comes down here next to the iron. The 2 from the iron comes down here next to the chlorine. Again, I don't actually need that 1, so it's going to be FeCl2. That's my final answer. For copper 1 bromide, copper again is a transition metal. It's got the symbol Cu. Because it's a metal, I know it's going to form a positively charged ion. Because it's got a 1 in Roman numerals, I know it's going to be +1. The bromine has got a -1 charge. +1, -1, they do cancel out, which means I don't need to do any crossing over. I just write down CuBr, and that is my final answer. Another thing they can ask you to do is they can give you the formula of an ionic compound, and they can ask you for the charges of the individual ions. In the first one, I've got iron bromide. Bromine is in group 7. It's always got a charge of -1. Always, 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 because it's in group 7. There are 3 of them, so overall you have got a -3 charge. That tells me that iron must be +3 to balance it out. Up here, when we looked at iron, we said it had a +2 charge, but the charge in an iron can change. It can be +2 or it can be +3. In this example, you were told by the number in brackets that it was +2, but if we look down here, the fact that I needed 3 bromines to balance the charge tells me that iron in this case must be iron +3, and then I've got bromine, which is -1. So they're the charges on the ions. Another example here, I've got copper and I've got Cl, and I need 2 chlorines to balance the charge on copper. Again, chlorine's in group 7, so it always has a -1 charge. There are 2 of them, which means I've got -2 in total. To balance out -2, I need +2, and that tells me copper must have a +2 charge when it's in this compound. Again, up here we saw that copper was +1, but again, copper, like iron, can have different charges. It can be +1 or +2, and in this example, it is going to be +2. A slightly harder example, I've got calcium nitrate here, and I want to work out what charge is on this whole nitrate ion. I know that calcium is in group 2, and if it's in group 2, then it must have a +2 charge. I can see here that I need 2 of my nitrate ions to cancel the +2 charge on calcium. If I need 2 of them, then that tells me that each nitrate ion has a -1 charge. Because if it's -1 times 2, that will give me -2 in total, which will cancel the +2 on calcium. So that's an example of using the formula to work out the charges, although you can also be given the name and be asked to work out the formula.